Good evening. Today we are going to see uh, design of steel structures, and in that we are going to see the steel structure and its type. So now we will see what is the teaching scheme. So we have 3 hours per week. Credit we have 3. In semester exam, we have 30 marks, and that we know that is on 2 units. And then on remaining 4 units, we have 70 marks. Now, fundamentals of what are prerequisite means what we require to study this. We have engineering mechanics. Already we have studied mechanics of materials. So that is mechanics of structures we have already studied, and structural analysis also we have covered. Now course outcome. So course outcome means after completion of this course, you are able to. So after completion of unit 1, you know what are the different type of steel structures, what are different steel code provisions, and what are the design adequate steel sections we can use for tensile force. That you can understand or able to design different types of sections for tensile force. Second, in first, we are with tension members. So we have tension member in unit number 1. So if we will go to second, so determine the adequate steel section. Again, we are going to design for compression load. That we are designing compression sections, that is for compression load, as well as we are going to design the columns, and columns we know are always as compression members, and lacing also, and lacing and battening we are going to provide for this, that is bracing. These two are bracings. One is known as lacing, another is known as battening. So in unit number 2 we are going to design compression member. So in unit number 1 we are with tension member, unit number 2 we are with compression members. Now go to third unit. We are going to be eccentrically loaded column for section strength and column basis for axial load and uniaxial bending. So try to understand first two we are going to be designed for axial members. Now if we will go to 3, then we have design eccentrically loaded column. If you revise mechanics of structures, then in unit number 5 we are eccentric columns, and here we have to design for axial load also and uniaxial bending. We have seen there uniaxial bending also and biaxial bending also. If my load is on one of the axis, then it will act as uniaxial. So if I can say we have, this will be uniaxial. And if that load is somewhere in between, then that will be biaxial. So we have third unit, that is axial load plus bending. So we have axial plus bending. That means we have, this will be compression. This will be axial plus bending. So not purely axial, not purely flexural. First 2 units we have purely axial. Then if we will go to 4, then we are going to design laterally restrained and unrestrained beam. So whenever we have beam, then we have this, we have to design for moment. And as we have to design for moment, this is known as flexural member. So we have this as flexural member. So unit number 4, we have purely flexural member. 5, we have to design truss, and we have to design gantry girder. This we have to design in unit number 5, and unit number 6 we have welded plate girder. So now we are this welded plate girder, again we have flexural member. Truss we have combination again axial plus flexural. Gantry girder again we are with flexural member. So girder we have maybe gantry or plate, we have flexural member. So likewise we have to go for, means after completing unit 1 we are in position to design tension member. Unit 2 we have compression member. Unit 3 eccentrically loaded column. Unit 4 beams. Unit 5 truss and gantry girder, and unit 6 we have welded plate girder. Now syllabus you can see. So in this we are going to cover types of steel structures. We are not going in detail with this chemical composition of structural steel in this, and we are actually not much related with this one. So that will be in 2 line, I will tell you. So in the class only. So then we will go grades of steel structure in next one, where we will see various IS codes. So that we will see in next video. In this we have steel structure and its type. So steel structures actually, so we have this as modern construction renowned for higher strength, durability, and versatility. That means we have flexibility in this one. So versatility means flexibility. So strength, durability, and flexibility. That is the advantage of these steel structures. Then we have these steel structures are composed of steel components. That is beams, columns, trusses, and these offer exceptional structural integrity and ability to withstand various environmental forces. So environmental forces means we can say different forces. So wind we can say for this wind we can use in this, that we are going to say different environmental forces. Then we can have these forces along with dead load, live load, that we have to consider. Now the main part of this we have, that is, so if I can say this main part, we have strength to weight ratio, allow for efficient use of material. Strength to weight ratio is high because these are lightweight structures, and therefore as we have this strength to weight ratio high, so we have these are use of efficient materials. And engineers can go open interiors, means we can have more space without any obstructions, means columns will not be there. Then this flexibility in design coupled with the speed of construction. So we can use prefabricated components and we can construct these buildings very fast due to these steel structures. And then we have beyond their structural advantages, steel structures are also environmentally sustainable due to the recyclability. Means if you will see its recyclability, this is around 80%. We can use these material about 80% again. Then we can have general advantages. So we have strength, already we have seen high strength to weight ratio. Flexibility, we can easily modified, expand or recycled. And therefore its recyclability is very high. And therefore we can say the structure we can shift from one place to another place. Then construction speed is very large, I already mentioned. So if we can use prefabricated components, then we can go, that is high speed for the construction. Then disadvantage is higher initial cost, because cost of steel is large, and therefore automatically total cost of the structure is large initially. Then corrosion needs protective coatings, because when it comes in contact with water or we can say air, then it corrodes, and for that one we have to go for protective coatings. Fire resistance, if temperature goes very high, then in that case it can lose its strength, and so that temperature we require, that is very high to lose the strength of the steel. Then type of steel structure. So we have steel frame structure, then we have steel truss structure, then we have steel arch structure, and steel cable and tension structures. So now steel frame structure. So in this we have simply as RCC structures, that is framed structures. We have columns, we have beams, and that we are going to use for this construction. And these we are going to connect using welds, bolts, or rivets. Now rivets are rarely used. Mainly we are going to use welds or bolts. Now advantages. So if we will go to this, so mainly this advantage we have everywhere, that is high strength to weight ratio, resistance to weathering. If we will take prior precautions, then it resists corrosion also, offer long-term structural integrity. Flexibility, we can change design in between also, and that we can have large flexibility if we will talk about steel structures. Speed, already I mentioned, is very high if we will use that is prefabricated components. And recyclability, I already mentioned, about 80% we have recyclability. Then disadvantages, we already mentioned, initial cost is high. Corrosion, so if we are not going to take any prior precautions, then we can have rusting of this steel components. Fire resistance, already mentioned, can lose strength at high temperature. Then we can have steel structure. So these are generally, if we will go, then I will show actually pictures in the class in these types. Then steel truss structure. Then you can see this steel truss structure utilize triangular units made of steel bars or tube supports loads over a span. Means we can have large open space in this case. There commonly we can see, if we will go anywhere, then for bridges and industrial sheds, generally trusses are used because of this triangular structure. These efficiently distribute forces, offering a lightweight. Advantage, again, lightweight structure. So we have high strength to weight ratio, and therefore we have high strength for this wind. Then resistance to weathering, already I mentioned. So flexibility, we will see, we have same advantages. Then speed of construction, we have large. Recyclability is large. Then disadvantages, same, initial cost, then corrosion, and then fire resistance. Then steel arch structures utilize core steel members to create a load-bearing framework that spans large distance without the need of internal supports. Then again, we can have more span between the columns if we will go by these arch structures. And this also enhances structural integrity also. Then advantages, clear span capability is large. Then strength and durability, already I mentioned it, aesthetically appear. So for this, we can have the curved shape, and therefore we can have itself, lends itself to striking and iconic architectural designs. Means we can go with large, good appearance aesthetically in case of steel arch structures. Resilience, this is again related with your fire resistance and speed of construction quickly again. Disadvantages, again same, but in this we have actually design complexity when we will talk about arch structural, and it becomes difficult for maintenance also. Then limited flexibility in this one, as if we have trusses, then we can have flexibility, but here we have limited flexibility and costly, because skilled labor are required in this case when we will go for this construction of this steel structures. Then we can say erection. In steel structure, generally we talk about erection, steel cable and tension structures. Now here we require very large skilled labors, and in this steel cable and sensor utilize high strength steel cables, and its weight is very less. Or rods, we can have cables or rods, and these are lightweight members in this case. These structures are known for their minimal use of materials. I already mentioned material required is very less in this case, and unique architectural designs. Advantage is very lightweight. Then design flexibility, we have in this also large spanning capability. Aesthetical appeal, in this case also we have too good durability. We have very large compared to other one. But in this, if we will see complex installation, it is not easy to install, because we have to go for precise tensioning. In this case, that tensioning may be pre-tension, or that may be post-tension, means before erection or after erection, and anchoring also during the construction. Then maintenance, regular inspection, that is for tension, we have to see this, and that is again a disadvantage for this. Cost, we have very large compared with other three also. Limited insulation, membrane materials used in this may provide limited thermal insulation compared to traditional building materials. So these are the different types of structures which we are using in case of steel structures. Now we will stop here only. Thank you.